Hello, my name is Monica and this is Lab 4 where we observed the magnetic field of a bar magnet. The purpose of this lab was to first measure the distance dependence of the magnetic field due to a small bar magnet using a magnetometer. Using these measurements, a graph was made in Excel. Next, the off-axis measurements were recorded and compared to a computational model with the same setup. Using the data from part 1, we can calculate mu from a derived equation. Furthermore, the experimental and computational results for the magnetic field at 45 degrees are compared. Principles used in this lab include the Biot-Savart law, which relates the magnetic field generated to a constant current. It can be used to derive other equations needed for this lab, including the magnetic field of a dipole caused by a magnet's dipole moment as seen. In addition, the distance dependence of the magnetic field of a bar magnet will be used in part 1 calculations, as well as the linearization formula used to create the graph from the on-axis measurements. For this experiment, the system was the bar magnet while the surroundings were everything else. For the initial setup of the lab, a bar magnet was placed at the end of a meter stick. For part 1, the magnetometer chip on the phone was found by first orienting the meter stick to compensate for the Earth's magnetic north field, where the net magnetic field should be 49 microtesla. Next, the phone is slid horizontally to find the max X value and vertically to find the max Y value. Tape was placed on each of these points, and the intersecting corner was the location of the phone's magnetometer sensor chip. The data from part 1 was recorded to create a graph based on the linearization formula given. The slope equation from the graph was used to calculate the distance dependence formula for the magnetic field. The slope, or n, was negative 2.956, r was equal to 1, and the natural log of k was negative 0.422. Plugging in the values to the formula, we found that the distance dependence of the magnetic field was 0.655. Next, to find the magnetic field moment of the dipole, the magnetic field formula was set up equal to the distance dependence formula and manipulated to solve for mu, which resulted in 3.275. For the second part of the lab, distance d-perp, for which the net magnetic field has a magnitude 100 microtesla, was found. Next, the Y component of the Earth's magnetic field was found by moving the phone along the meter stick. A second meter stick was added and aligned at a distance d-perp from the first meter stick, and the same steps were repeated to find the X, Y, and Z components of the magnetic field and recorded on the Excel sheet. Finally, to correct the Y component of the bar magnet, the column BY Earth was subtracted from BY measured. To begin with, the bar magnet was created at the origin, the magnitude of the magnetic moment from the previous calculation, and a function for the magnetic field of a dipole was defined. Next, the magnetic field was visualized by creating 2 arrows for the magnetic field on the axis and 4 arrows for the magnetic field perpendicular to the axis. Finally, the average d-perp for the second part of the lab was defined, and the magnetic field 45 degrees from the axis was visualized. As a result, we found that the magnetic field at 45 degrees from the axis in the computational model was 2.59 to a power of -5. Potential errors in the lab include electronic devices nearby affecting the magnetometer accuracy in its readings and the precision of the magnetometer's location. From part 2 of the lab, we found that the magnetic field was 4.62 raised to -5, while the computational magnetic field was 2.59 raised to -5. Based on the two results, the experimental result value was about 2 times greater than the computational result due to potential errors and real-world situations. If the meter stick had not been oriented to compensate for the magnetic north, the Earth's magnetic field would interfere with the magnetometer reading, causing the results to be skewed and inaccurate. Finally, if the experiment was repeated with 2 identical bar magnets, the direction of the magnetic field would remain the same. However, the magnitude would likely double. Thank you for watching.